Hello, this is Happy Potato speaking, and this is not procrastination. This is part 2 of the section 2 of the Edexcel IGCSE Physics Syllabus called Electricity. Way! In this video, we'll be going over energy and potential differences in circuits. I love circuits. Series or parallel or series. Before we can even choose which is best in any given situation, we have to know, first of all, what each of them mean. A series circuit is when everything is connected in a straight line, like this battery and this light bulb. This is a series circuit. This is a series. When something is in parallel, as the name implies, it is as if there are two series circuits connected together so that there's a part where there are two wires which are parallel with each other like so. So when we make this extension, this is a parallel circuit. In physics, there are some reasons why using a parallel circuit will be more useful than a series circuit in some situations. For example, in the electrical wiring for a Krispy Kreme donut shop, it's more likely going to be in a parallel circuit so that each light can be switched on and off independently in the building. In a parallel circuit, different components are connected separately to the supply, which means that if one component breaks, the others can continue being powered as the whole circuit is still functioning. This makes it practical to use. So to put all of that basically into a simple diagram, we can have a switch here, and we can have a switch there, and a switch here. With a parallel circuit, you can switch all of these lights on and off independently. So you can have this one on, you can have this one on, and you can have little dots to show where the switch starts and stops. And you can have this one on, and you can have this one off, and you can have this one off. While in a series circuit, in comparison, we have a switch and a light bulb, and if one of the switches, say you have another light bulb there and another switch here, if one of the switches is open, like this one, this is a switch that's open, then the entire circuit won't work. This bulb will be off, and this bulb will be off. In a series circuit, let's say this amp meter, this is a symbol for an amp meter, reads 5 amps, and there are two bulbs connected in series. Then each of these will have 2.5 amp readings because they share the amps, they share the voltage. So we can also change this to volts, make that a voltmeter, and say 5 volts from the voltmeter is shared evenly across the two bulbs connected in series. However, if we had them connected in parallel, if we had only one bulb here and one bulb here, and we had a voltmeter here and a voltmeter here, both of these voltmeters would read 5 volts. They don't get shared. They are completely the same throughout the entire circuit when it is a parallel circuit. However, in mega stores like a Home Depot or one of those really big Walmarts in the US, Walmart, maybe Target, I'm not sure how many rings it has, Target. Or if you're in the UK, Waitrose and Tesco. What do all of these shops and stores have in common? Well, they're all incredibly wealthy, yes, and also in all of their buildings it makes more sense to have the series circuits in place in the lights. Why? Well, if we imagine that all of these supermarkets are super big and they all need all the lights to be on at the same time, it makes more sense to just have one mega on switch. Rather than thousands and thousands and thousands of tiny small little ones. It just makes it easier to switch all the lights on or off at the same time instead of going through every single individual light switch. Another example of this is one of my favorites. Hopefully you can tell what this is without me even having to say anything. Yes, these are Christmas lights. And the great thing about Christmas lights is, 1, they're very colorful. 2, they remind me about Christmas. I think that perhaps we could mention a negative aspect of Christmas lights. And that is, if one of these bulbs explodes and has a horrific death, it automatically means all of the other Christmas lights turn off. It breaks the circuit, just like the fuse did. So now all of the Christmas lights are off. And if it's not completely physically broken, as it is here, let's say it's just a wire here is broken on the inside, we have X-ray vision here, we wouldn't know what would be the cause. We wouldn't know where the problem would be. And all of them stops working. And that is one of the downsides. But it's not all bad news for the series circuit. They are the patrons of the Christmas spirit. God, that sounds terrible. And they are relatively low energy circuits. So since the circuit in a series circuit is shared throughout, since the current in a series circuit is shared throughout all parts of the circuit, to work out the total current of a circuit, we can use the equation current equals voltage over resistance, which is basically rearranging the equation voltage equals current times resistance. The unit for current is amps. The unit for voltage is volts. The unit for resistance is ohms. So the current in a circuit is total of the voltages received by the components divided by the total of all the component resistances. So if you increase the resistance of the circuit, the current will decrease. Basically, everything you put in a circuit gives resistance. Resistors, metal filament lamps, diodes, even switches to an extent. Everything you put in a circuit gives some form of resistance. A usually helped me was thinking about resistance like the width of a pipe. So if we have a really wide pipe and a really thin pipe, which one would it be easier for water to flow through if we had the same amount of water in each case? Well, this one. Why? Because it's just easier for the water to move through this pipe, because there is less resistance to the water as it moves through. The same thing with electricity, except with resistance, the width of the wire doesn't necessarily change. So let's say this wire has more resistance because it has a lamp on it. If you found this video helpful, please leave a like and subscribe. And if you have any feedback as to how I can make these videos easier for you to revise from, then please feel free to let me know in the comments.